Hello, my name is Sabine Winterkamp, and I would like to welcome all of you to our jam session today. Dan York is presenting, how do you hear me now? The power of wideband HD audio. Dan, ready to go.
Great, thank you, Sabina. Welcome to everybody who is joining us for this developer jam session. It's great to have such a good crowd here, and I'm looking forward to talking about what we're doing here with wideband audio and the importance of wideband audio and the role it plays in kind of moving beyond the traditional telephony of the PSTN. A couple of logistics first. Please do ask questions through the GoToWebinar interface. We'll have a block of time when this presentation is done, when we'll be glad to answer any questions that you have. If you're tweeting about any of this, feel free to throw on the hashtag Voxeo on anything you do out there. And we will be doing an archive of this, or an archive of the session recording, and the slides will be available for later viewing at blogs.voxeo.com/jam sessions. The recording will not be in wideband because the GoToWebinar only does narrowband connections, but there is a wideband conference bridge if you'd like to join in and listen in wideband. I am currently connected into that through an iPad, actually running Bria's new Counterpath app that's connecting in over SIP into that conference bridge, which is running on Tropo, actually. And so feel free to join in if you'd like to. We'll get into some of what all that means in a few minutes. But let's begin by talking about why wideband in the first place and what's the reason why we've invested in it, why are people concerned about it. If you think about typical audio, the way that we speak, the sounds that we do, all of that, we cover a wide range of frequencies from our voice, going from basically very low, low, low to very high. And there's a wide range of frequencies that make up the human voice and human hearing. The issue that we have is that the public switch telephony network, the PSTN, the phone network that we're used to, only takes a small slice of that. And this picture isn't actually even accurate. It's even a little less than this. But this is a basic little idea of what you're seeing, is that it takes all of those frequencies, and we only see a small bit of that coming through the actual phone network. The challenge, of course, is that this leaves us with the audio experience we've had. With wideband, we have a couple of different advantages. One is that feeling of being there. If any of you have used Skype, and many of us have, of course, when you have a really good Skype connection, it almost feels like you're right there in the room with people. I've been doing podcasting for now, I guess, over 6 years. And very frequently, I would record my podcast with my co-host when I was doing Blue Box, the Voice over IP security podcast. And we do it all via Skype because it would sound like we were right in the same room, practically. It was just like we were right there. And that's really the single biggest thing that wideband can bring, is this ability to go and make you feel like you're right there with people. Now, there's some very technical reasons why wideband's a good thing. One of them is just better understanding. There's certain letter sounds, sibilants, and other pieces that are part of our speaking that don't work well, or that rely in narrowband and rely on higher frequencies. Things like pale and veil, or sail and fail, and words that you would wind up with where the like gold versus bold versus gold. What are those? There's the nuances of audio that we can't necessarily hear when we're in a narrowband environment, in a typical phone environment that we would have today. There's also, along with that, the whole multilingual aspect. When we have people who are speakers from other languages, and they are speaking English perhaps as a second language, their accent may make it more difficult to hear the language that's there. And part of what's happening, again, is that reducing it to the narrow spectrum that makes up the PSTN, we're removing all of those upper and lower level frequencies, which help us so much in the tonality of that. So for multilingual purposes, for that ability there, it's a key part of things as well. Longer conversations. There was a number of different resources out there, a number of different surveys that talked about how, because people find wideband audio much more appealing, much more conversational, they will go and they'll have longer conversations. They'll engage more. They'll interact with people. They'll talk more in a wideband environment than they would over a traditional phone conversation. There's also some good research around the fact that it is, in fact, less fatiguing on the on the person participating in the call. And that has a lot to do with the fact that when you're in a narrowband call, a traditional call, your brain is doing a lot of processing to try to make sense of what all is going on in there. Particularly, you know, if you've got a cell phone connection or something where you're winding up somebody cutting out, and you're like, hey, Fred, what'd you say? What are you trying to get there? You know, your brain is actually doing a lot of extra work to try to make sense out of what is being heard there, and to do things like that differentiation between goal and gold or something like that, to be able to ensure that it's there. So your brain has to do a lot of extra work, and so with wideband, you actually wind up having a less fatiguing conversation, which goes back into that idea that you wind up having longer conversations and longer interactions. With Voxeo, I mean, a lot of what we look at is automation and pieces like that, and wideband offers a lot there, because when you look at speech recognition accuracy, the accuracy of an automated speech recognizer, an ASR, is widely determined by the quantity of data that it is able to go and use. And so if it has more data, a wider range of frequencies, a wider sample to be able to go and work with, the speech recognition can be much more accurate, because you can be able to have that larger sample size to go and be able to determine that. So it helps with the recognition, which helps then into any of the kind of self-service applications or other tools that you might use with that. It also helps in areas like transcription. You know, we look at services that are common these days where you can get your voicemail, automatically transcribed to you, and some of those, that again, it goes back to the recognizer. What can it do? If it has a larger sample size of a wideband audio, what can it then do to be more accurate and wind up with solid transcriptions? Another area that's interesting is, again, the whole space around voice biometrics. And once again, you've got a larger sample size, which then the biometrics engine can be able to use to determine, what was that person really saying? Was it truly a match to the voice print? What was the true liveness of the sample? All of those different pieces together provide reasons why we're looking at wideband. So let's get a little bit into some of the details. The first detail, of course, here when we start talking about wideband is that this relies on voice over IP. We're not going to do this in the PSTN because the PSTN shackles us to the legacy narrowband that the PSTN has. But with voice over IP, and in our case in particular, SIP, the Session Initiation Protocol, we now have the opportunity to move beyond the limitations of PSTN audio and get into a true wideband, high-quality audio experience. So to think about it, human hearing typically is referred to as being in the range of the frequencies from 20 hertz up to 20,000 hertz. And there's, lots of people who will have different, pick apart whether it's really that or whether it's to 15K kilohertz, et cetera, et cetera. But the point is that it's a wide range of this, and as we get older, our frequencies diminish, and as we're younger, our frequencies are up on the higher end, certainly. There's a wide range in there. And so that's human hearing. And the PSTN reduces all that to a range that is simply 300 hertz to 3,400 hertz, a very narrow space within the larger frequency range that we have. And that's that telephone sound that we're used to. Now, with wideband codecs and with the tools that are out there, that range actually goes up significantly. Many of the codecs, and we'll talk about that in a few minutes, the codecs are out there. We'll do things like a range from 50 hertz up to 7,000 hertz is a typical one for G722 and some AMR wideband. Some of the other ones are there. Others, some of the newer ultra wideband, super wideband, other different terms, they'll go even higher and encompass an even larger frequency range. Some going up to really the whole range that human voice has. So that's what we're doing, is we're going beyond this, little scope to getting into a much wider scope that we have. Now, a part of when we talk about codecs and about wideband audio, one of the terms we need to think about is what's called the sampling rate. And that is the rate at which the device transmitting your audio takes a sample of your voice. And so a typical PSTN audio call samples at 8 kilohertz, or 8,000 times per second. It's taking a sample of your voice, and it's capturing that. And so in a graph chart, you get something that looks like this, as you can see on the slide, that shows the various different points and the pieces that are there. And that's how it samples it. Now, with wideband, we start looking at sampling at a higher rate. In this case, I'm showing 16 kilohertz, so 16,000 times within a second that it's going and sampling the voice. So it's getting a much clearer picture if you compare these two. I'll switch back there to the sampling rate of 8 kilohertz and then moving on into the sampling rate of the 16 kilohertz. You're getting a much cleaner curve, a much more defined curve. You're getting a much richer sound of seeing what's out there. So sampling rate is a big part of what defines an audio codec, and from a narrow band to a wideband. And there are codecs like the Speaks codec, which will go out to 32 kilohertz in sampling. And some of the newer ones, even the Opus codec and some of the others, will go out to 48 even. So a much richer range of doing that. Now, another part, the PSTN is a sampling rate of 8 kilohertz, and G722 and many other ones are sampled at 16 kilohertz. I mentioned Speaks will go from 8 to 16, actually all the way up to 32 in this regard. Another part of what you need to think about is the bit depth, or sometimes referred to as resolution of the codec, in terms of with each sample that it does, each of those 16,000 samples a second, how much audio is being captured in that time. Is it 8 bits worth of audio? Is it 16 bits worth of audio? That, again, determines the amount of resolution, the frequency response, and pieces that you're seeing inside of that. So it's a part that's there. Another piece you'll hear talk about is the bit rate, which is basically the rate at which the data is being sent out on the screen or streamed out to you. So when you're streaming it out. Now, if we look at a lot of the different codecs that are out there, there's a real alphabet soup of codecs that are out there. G711 is standard audio in the PSTN terms of things, the digitization of PSTN audio, narrowband audio. And then we have G722, G722.1, 22.2, none of which are actually related. 722, 722.1, 722.2 are 3 completely different algorithms, but hey, whatever. Speaks is one we'll talk about. ISAC, Silk from Skype, Kelt, and there's a new project underway called Opus, which is to come up with basically the G711 of wideband, a widely available patent-free, royalty-free type of codec that could be used for wideband communication. It's work underway within the Internet Engineering Task Force, or IETF. Let's just compare a couple of these. We can see how they work. As I mentioned, G711 has a sample rate of 8 kilohertz, a bit rate of 8 kilobits per second, and it's the standard that we have for narrowband audio, and that's pretty much every voice over IP system out there supports G711. And yes, there's a G707 U law and A law depending on where you're coming from in the world, but basically that's the same idea. It's 8 kilohertz, 8 kilobits per second, and that's standard audio that we would have. G722 is kind of the standard wideband codec that many people are implementing, and it does 16 kilohertz sample rates, and its bit rate is 64 kilobits, and that just means it's a larger size when it's being transmitted and all of that, which is one of the challenges of when you start to get into wideband is, the size of the stream, the size of the recording, all of those different pieces. At this point, many of the patents and other pieces around G722 have expired, and so it's actually widely implemented in a number of different IP-PBXs and endpoints and pieces that are out there. So it's common out there. G722 is AMR wideband, it's referred to, and it's 16 bits. It's one that's becoming more interesting or more popular because of its endorsement by the 3GPP and mobile carriers starting to go and roll that out in various different areas as far as providing a wideband experience over the mobile network and being able to work with that. Speaks, I show here, again, has various different sample rates, variable bit rates, depending on what you're doing on that. It's open source for that reason. There's a good number of folks who have implemented it in various different platforms and different solutions. We've implemented it, and numbers of other vendors and folks out there are using it. And it's a very powerful codec for use out there. Another one you're hearing a lot of good conversation about is Silk, which is a codec out of Skype, and what Skype uses in all of its newer clients, the 5.0 clients and pieces that are there. And it has, again, various different sampling rates. It is a proprietary protocol in the sense that it is from Skype, and you have to license it. But they're trying to promote it out there as easily licensed by folks there. Now, all of this is kind of leading to where I mentioned here OPUS, which is this work underway within the IETF to standardize basically a G711 of wideband. And somebody on the wideband bridge is unmuted, and so we're hearing, well, no, thank you for muting yourself. Okay. So OPUS is, again, this work in progress, and the goal of it is to be able to get to a point where we could have a widely implemented codec that would work for wideband that offers more advantages than, for instance, the standard G722. With the OPUS has various different ways to have a low bandwidth connection, and so you could be able to have, it being used in various different voice over IP environments that G722, for instance, may not work as well in. So that's some of the codec examples. There's a lot more out there, but these are just some examples for you to see what's going on. So let's talk about how it works in SIP, because that's part of what gets into where this all fits in and the pieces that are part of this. So to negotiate the codecs, there's a critical part of SIP called SDP, or the Session Description Protocol. And what happens is it's an offer-answer. And what goes on is basically if Alice is calling Bob, she sends along in her SIP messages, she says, hey, I can speak these codecs. Which ones can you do? And Bob replies back and says, I can do these codecs. And they agree through the offer-answer process that makes up SIP. They agree on which codec they're going to use, and they go from there. So as you can see on the slide, here these two decide they're going to use G722. That's how that works. And in the SIP and typical call flow, you have the invites that are flowing back and forth, or going from the first one over to the second, and then the OK coming back, the ACK. And in that process, in the invite OK ACK process in there, that's where the SDP packets are being exchanged. They're part of the offer answer that is going to agree on what is the way we're going to go and do this communication. So that's how this is working. Now, unfortunately, the picture that I showed you of Alice and Bob, is a nice idealistic picture. But when we actually look at how it truly looks, it's a lot more involved of an actual process, because of course we don't just have simple direct communication. We have media proxies, we have media gateways, we have pieces like that going through all of the different areas. So you have to go and do some kind of negotiation on the edge of the network, perhaps. You have to have that kind of connection, and that's a challenge. Can you get end-to-end with a wideband connection? If I'm calling Michael, somebody I know who's on the call, and we're able to make our connection, can our media get through various different media gateways or other pieces and be able to go through there? So let's talk a bit about wideband audio and Voxeo Prophecy and PRISM, the products that we have here. Prophecy, if you're not aware of it, is our primary application platform. You can download it and install it for free. It's voxeo.com Prophecy. You'll see it in a minute. It scales literally from 2 ports up to thousands. Very solid in voice XML, CCXML, all of these pieces. Our 10.1 release recently added in support for IPv6 and wideband and what else is fax. People built all sorts of apps around it, everything from very large-scale IVR systems down to notification systems. We have a lot of people doing voice verification, voice outbound messaging. Basically anything you can do to hook up a phone to it, people have done. From these large-scale systems to Facebook apps that bring people together into a conferencing system, and pretty much everything in between. We also, Prophecy works with an idea called unified self-service, which is the idea that you could build one application once and then work across multiple channels, whether it's voice or IM or SMS or social or any of those. On the voice side, obviously, is where we're focused here in this particular piece. But you can go and download it and get it for Windows, Linux, or Mac OS X. I'm going to talk about the configuration. First of all, many times it should just work. Here I'm showing calling into this conference, actually, and I'm connecting in over G722, and it's working. The negotiation has occurred, and it's going on in this regard. Now, Prophecy supports G722, speaks AMR wideband, or also 16-bit PCM as well out there. But basically, these are the codecs that it supports. Now, to configure it, what you need to do, if you want to configure priorities, I should say, if you want to promote the wideband and have those be the ones that are primarily connected on versus the others, you can go in, once you install Prophecy, you can go into the config directory and go into the config.xml file. And there's some settings in there that you can configure. And there's a a file called config-reference.xml, which will show you what you need to do to go and configure it. And just to show you real quickly what it looks like, there's basically a category name called SDP codecs. And you would create a category for one of the various different types of things and indicate whether it's disabled, which you're not going to do typically, but the priority piece is the key element. I'll show you an example of this in a moment. The default priorities that Proxy has is to go in this order, as you can see. The priorities it would offer would be G711, then speaks at 8 kilohertz or 16 kilohertz, and then it goes through the other ones, 726, 729, et cetera, down to AMR and the others that are part of that. So that's the default priorities that are set up in Proxy 10.1 today. If you want to change that, you can just go and modify it basically by changing around the configuration file. And you can see here, I put in here category name G722, priority 3, speaks 32,000, priority 1, etc. And I deliberately put them out of order to show you that it doesn't actually matter the order of these. It's the priority item that is the important part of things. You can see at the bottom, in this particular case, I've actually gone ahead and disabled G711. Oh, actually, so it's always going to connect over these over wideband codecs. So that's a bit about how it's set up here. There's also another piece too that I should mention, which is that we do have a mode where we can force the priority of the local codec. So by default, what we'll do is we'll look at the offer that we get from the receiving endpoint and communicate on what is offered to us by the default. We do have the ability to force the server to try to use its local priorities over what is going on in that regard. So again, you have that choice as well. Once you've done that, all you have to do is go and restart Proxy, and you can start talking in wideband if you've changed around the priorities like that. Again, you can download the free 2-port version and try it out. Now, let me touch on PRISM, because PRISM is another product we have, which is a SIP and XMPP application server. Some of you who have been around Voxeo for a while may have known of the product we had called SIP Method, which is a SIP application server, but PRISM is basically a SIP method because we had to rename it because we've added in XMPP. It's much more than just SIP at this point. It's also now a media server, IAM presence, and it's really designed to be a carrier-grade product. It's what underlies Proxy, it's what underlies Tropo, it's what underlies so many of our other products. It's really the base layer of what we do. People are using it for very high-demand call control apps. Basically, a number of different service providers are using us in IMS as an application server and the pieces there, and also for core routing within a SIP environment. So you're seeing a lot of different pieces that are here. And let's see, we talked about converged SIP. I already mentioned this. It scales literally from hundreds of setups to thousands and tens of thousands more on there. So again, on the PRISM side, wideband audio was added in 10.1 in May, and you can go and download it for free at www.voxeo.com/prism. Now, the next steps I will just mention now that we're done with this. I'll open up some questions. I see we do have some questions coming in. Our next GM session will be in early July. We're aiming lining up the time right now, but it's going to be around location-based services, looking at how we can use geolocation information using voice objects and how we can get into doing some of that. So stay tuned. Watch at blogs.voxeo.com/jam sessions to go and understand more. And I had another best practices will be our voice objects business user interface, survey management framework. We're partnering with our partner Excelsis to talk about how they can go and build well, as it says here, survey management framework. That's going to be coming up on June 28th, and you may find that of interest as well. Now I want to open up for some questions and answers, and I see a couple. Somebody asked me about what codec I'm connecting in on the wideband bridge. I'm connecting in on G722. I'm using the Bria Counterpass Bria softphone for the iPad, and it supports G722. It does not support Speaks. I was asked if I was connecting on Speaks. I have another question from Michael Graves telling me that G711 is 64 kilobits versus 8. Really? Okay, I'll check that, Michael. But I know you're working in the wideband space, but I was fairly sure it was 8. But we'll check that. I have another question here. Will Voxeo support the Silk codec? Well, we're certainly watching that. It's from Skype, etc., and Skype has offered to make it available to people for, excuse me, for, oh, of course, Michael interrupted me to say G729 is, of course, you're absolutely right. Yes, G711 is 64 kilobits per second, and G729 is 8 kilobits. Yes, you're right. I was confusing those two things in my brain. Good catch. Thank you, Michael, for mentioning that, and thank you for Julian for passing that in there as well. So back to the question around Skype and or support for Silk. We're certainly looking at what the Silk codec is all about. Silk is proprietary from Skype. They're trying to push it there. There's certainly questions around the long-term, support for it, et cetera, and what goes on with that. I think we're much more interested in seeing where the whole Opus process goes within the IETF, which is the merging of several different ideas. It takes some things from Silk, some things from Kelt, from a couple other different protocols, and puts them together. So it'll be interesting to see, because if we could get to a place where we had a ubiquitous wideband protocol that is like a G711 for wideband, that would be truly an excellent thing for us to do. So are there more questions do people have out here? I'm looking in the question pool. Come on, folks, you can't let me off this easy. You got to throw some more questions at me. Michael must have some questions around here. And I'm opening up the wideband bridge to listen to it as well. So if people have questions there, you can ask them to me directly, and I will relay to the GoToWebinar bridge itself. Okay, I have a question coming in. Go ahead. So the question is around SIP peering and security, and what kind of steps you need to take if you're going to be doing voice over IP and connecting in through through a peering environment like this, where you are moving to a true voice over IP space. Well, we could get into a long webinar on that itself. Some of you may know I wear another hat as the chair of the Voice over IP Security Alliance, and have done a lot of writing and done a lot of talking around voice over IP security. But the answer is that if we're moving to a voice over IP space, we do need to look at how do we secure that connection to be able to go and have secure communication across that. Depending somewhat upon what the risk factors are, what the pieces are, where you're connecting over. If you're within an internal network, if you're going across the internet, if you're going across an MPLS network or pieces like that, you have to look at what the profile is of an attacker, how they could go and do it. But the technologies to secure it are well understood. We have a secure RTP mechanism, what's called SRTP, which provides a way to very quickly and easily go and encrypt an RTP session, RTP being the real-time transport protocol. That's very well understood to be able to go and use that. It does not add a whole lot of overhead to the communication channel. You can see it. It's what Skype uses, what many other people use out there. We also have very well understood ways to go and secure the SIP connection and be able to put it in as TLS or other pieces like that. So the answer is the solutions are out there. We just sort of have to go and decide to implement those, to enable those solutions that are there. So that's and I could go in at quite some length around this. And if you've got more questions, feel free to ping me at dyork@voxeo.com, and I'd be glad to answer you at some greater length. I have another question. From somebody who says, when did Tropo start supporting wideband conferences? I don't see anything in the docs. Is this automatic now? Well, you're getting a little preview of what's coming up. This is Tropo itself directly does not support wideband today, but this is a special conference bridge put up by the Tropo team that is running on the latest and greatest PRISM 10.1, that supports the wideband audio conferencing. So expect to see this coming soon inside of Tropo. But for today, we have it on this test bridge that's there, and you'll see more of that coming up. When it does come in, it will be something that will just be kind of automatic that happens in there. I should note, too, the wideband bridge that a number of people are connected in on, it is running on our tropo.com cloud communication service, and it is all of a 3-line Ruby script. That's all that was put together to go and make this possible for us. So that's why in the bridge, in the notes too, I indicated that there was no muting on the conference bridge, because it's not that complicated of an app. It's something that our chief architect Jose de Castro put together and deployed on there. And that's what we got on there. So Tropo will come soon. Let's see here. I got another question. What are the transcoding solutions that are used in Voxeo's platform, software-based or hardware-based? We're software-based. So all we're doing inside the product is based in software. How PRISM is different from other, okay. I'm not entirely sure what, how's PRISM different? I'm sorry, you may have to explain a bit more what you're asking for. I think for an ITSP, for an Internet Telephone Service Provider, PRISM provides a platform for SIP applications. So you could use them to do things, SIP and XMPP applications. And some of those might be SIP servlets. So if you're using the Java environment to go and create those kind of applications, it's a very robust applications that are for doing those kind of things. There are people who use it for core routing. They use it as part of the SIP call routing infrastructure that they have and what they do with it. And it's really a platform for creating those kind of applications and using them in that space. Michael asks, could I play some music or something to eject a really definitive wideband sound sample? Well, Michael, why don't you and we could stay around after the session's over, and I could do some things in the wideband bridge, because the people who are on the GoToWebinar session will only hear it in narrowband. So I could play some music, but it won't really make a whole lot of difference to what they're hearing on that side. And somebody else says, thanks. Somebody says, oh, PRISM and Prophecy, what's the difference with them? Okay, good question. So PRISM provides it's a lower layer that provides basically the framework upon which Prophecy sits. So when you actually get Prophecy has PRISM built into it. And so Prophecy sits on top of PRISM to go and do a lot of the core routing, the core down there at the SIP layer and all the pieces there. What Prophecy provides on top of it is an environment where you can create applications in Voice XML, CC XML, our own Call XML, using our graphical designer tool, pieces like that. It provides that functionality on top of it to create applications in that space and be able to work with it. So the combination of them gets you that. Now, if you want to write at a lower level, you want to get down into SIP and into SIP servlets and pieces like that, you could just use PRISM all by itself. But if you want to use Voice XML, CC XML, Call XML, and graphical tools, or more advanced environments to go and create applications like that, that's where Prophecy comes in to be able to work with that. So there we go. That helps explain what that was. Thank you for writing that back in. How well does the wideband work with, okay, so somebody asked me here, how well does wideband work with mobile data networks? Has there been any study that compares the use of some of the other wideband codecs that Voxeo uses versus Skype? So to the mobile network, the wideband usage within the mobile network, in the mobile data network. Okay, I don't know if we ourselves have not necessarily done any direct studies of that. We've just put out this release just a couple of weeks ago, actually, in this regard. But we support some of the codecs that are widely used, like AMR wideband, which is becoming a codec that is being widely used in the mobile environment. We also support the Speaks protocol, which is very widely used in wideband environments, especially in the open source and in a lot of the mobile data networks and the pieces like that. So I don't have samples right off, but I'll take it as an action item, something we can go and do to provide some information out there about that. So that would be that. Any more questions? Okay, I don't see any more coming in right at the moment. So if there are no further questions, I will say thank you very much for attending. The session will be archived, as we said again, on blogs.voxeo.com/jam sessions. And you can also go, if you go to, again, www.voxeo.com/prophecy, you can download version 10.1 right now, and you can experiment around with it on Mac or PC or Linux. Install it on any of those, and you can get it up and running, working with that, and using it with wideband there. So we'd love to hear your comments, your feedback as you work with this. Please feel free to email me. I'm dyork, D-Y-O-R-K, @voxeo.com, and you can email me at any time. And we'd be glad to work with that. And PRISM is, again, available at this. Oh, wait. Now we do have some questions. So folks coming in about Silk and what I think about Silk and Silk over SRTP and some pieces like that. And I'll answer those questions in an email to folks because I don't have a precise answer on Silk over SRTP. Somebody just threw a comment in there that says it has some weaknesses. I mean, Silk, from a codec perspective, is a neat codec. It's got some great capability to it if you have used Skype at all lately, the silk capabilities are quite strong, or the audio capability is great. I think really the question that folks have been looking about is really just the long-term licensing, long-term viability of that codec. If they were going to implement it, what are the reassurances around it? How safe is it to go and implement that, given the future of Skype, and now Skype is being part of Microsoft, etc. So we'll have to see where all that goes. But I think again, where a lot of the folks in the open standards world are looking at is what is the future of this Opus codec that's being developed within the IETF. And that's where I'm personally looking at seeing where that all goes. So and the other piece I'll mention too on that, I will say too, is that Google did recently open source a bunch of their codec work through the Web RTC project, or RTC Web, depending on which way you want to say it, which is a project to go and do communication from within browsers. And so there'll be some more interesting codec work coming out of that as well that'll be interesting to see, and how much wideband is in that and other pieces. So with that, I'll wrap up here and say thank you all for attending, and we will go on from there. And one last question. There was a question, do we need to install an encoder or decoder to use the codecs? No, it's built into the media server. It's part of Prophecy and PRISM. So just you download Prophecy or PRISM and start it out and work with it, and you can go from there. And it's all built in right there. So thanks a lot. We'll look forward to seeing you next month, where we talk about location-based services and some of the cool things that we can do there. Thank you for your time.
Thank you. Bye.